In this video, we're going to discuss states of matter and densities. So we'll go through the basic states of matter. So starting with solid, it has a definite shape and definite volume. Now you've probably heard this many times. So what does that kind of look like when we're talking about the structure of a solid? It's tightly packed molecules. Let's say we had like a cube structure that are all tightly together. No matter what container it's in, it's going to have the same shape and the same volume. Now a liquid does not have a definite shape, but it does have a definite volume. And so if you put a liquid in a cup, then the volume is going to be the same whether you put it in a cup like this or maybe a taller cup. It's going to have the same amount of volume, but the shape is different. And so when we talk about this ideal fluid, it basically means that it's made up of molecules. It's not viscous. It doesn't have like fibers type structures, and it's incompressible. And so what incompressible means is that if we had this fluid here, let's say there's like molecules and we have like a piston pushing down. Even if we applied a force, the volume would not change and the piston would not go downwards, and that's what incompressible means. Okay, and so gases have no shape or volume. So let's say we put a gas in like a container like this, and it has some molecules in it. It's going to depend on the container how much volume this gas takes up and the shape it takes, which means a gas is compressible. So let's say we had a piston on a container like this, and we pushed it down to, let's say, here. Now the same amount of gas is going to be in here, but it's going to be pressed to a different shape and a different volume. And we'll denote this difference is by the difference in pressure, and we'll talk about more about pressure in the next video. But in this video, let's talk about density, which mainly when we're talking about density, we're talking about solids and liquids. So the density is given by this equation here. This is called rho, which is what the symbol we use for density, and it's the mass over the volume. And so if we had, let's say, like a cup like this, and we had maybe like some thick liquid at the bottom, and then maybe there's like a lighter liquid up here, and then we have like a ping pong ball on the top. These are separated by their densities. So this bottom one has the highest density because it is at the bottom, so it has the most mass per unit of volume. And the least mass per unit of volume is the ping pong ball at the top. Okay, so let's look at an example using density. So water has a density of 1 gram per milliliter. A block with a volume of 8 milliliters is placed in water. How much mass can the block have and still float on the water? Okay, so let's write out what we know. We know the density of water is 1 gram per milliliter. And we have a block that has a volume of 8 milliliters. Okay, how much mass can the block have and still float? So we want to find the mass of the block where it's still floating. So let's draw this out. We have a cup here, and there's water and there's a block. And we know the block's volume, but we want to know the mass while it's still floating before it sinks, which means that the density of the block must be less than or equal to the density of the water. Okay, and so for our case, we want to find the maximum it can have before it sinks, so we want to know when these densities are equal. That'll give us that max mass. So we know the density is the mass of the block over the volume of the block must equal this density of water, which they gave us, and which is known. And so now we can multiply the volume to the other side and get the mass of the block equals the density of the water times the volume of the block, and plug in our known variables, 1 grams per milliliter, and our volume is 8 milliliters. So the milliliters will cancel, and we get that the max mass of the block can be 8 grams before it starts sinking. Okay, so hopefully that was helpful. Leave your questions down below, and in the next video we'll start talking about pressure and discuss the differences between absolute gauge and atmospheric pressure. So make sure you stick around for that, and thanks for watching.